Hi everyone. Welcome to the first coding tutorial of neural networks and deep learning. My name is Eberly. I am one of the TAs of this class and I will be leading all the coding tutorials for the semester. So for today's class, we have a couple goals here. We will practice how to use Google Colab to run Python scripts. And today we will mainly focus on using Scikit-Learn library to train and evaluate a neural networks model. So throughout this tutorial, we will learn how to read through the library documentations, and that will help you understand the packages and functions so that you can apply them in your codes accordingly. So before we start, if you have not yet have any experience in Google Colab, it's very simple. So it's incorporated in Google Drive. You can just start a script from your Drive directory and here, so you can run any code on Colab. And before running this script, I would like to ask you to copy the script that I share with you to your own directory, so that you can edit and run the script. All right, so let's start from outline. So first of all, we're gonna load datasets from Scikit-Learn toy datasets, and we're gonna pre-process the data. That would include splitting datasets into train and test, and normalizing those sets. And the third part, we are going to train a neural network model, and after training, we will practice using evaluation metrics and also confusion metrics to evaluate how the model does on testing set. Um, and we have a part 5 here that in this part we will teach you how to plot accuracy over epochs, and that will provide a good aspect for you to learn about this model that you create. Okay, so let's start from part 1. Um, so here's the Scikit-Learn website. Um, Scikit-Learn is a powerful and very commonly used machine learning library in Python. It's very convenient. If you go to their website, you can see all these different types of models and functions like preprocessing data that you can use. So today we're going to cover the data part. And with model, we will use classification model as an example, and also for evaluation metrics. But there are like all these other stuffs that you can check out. I recommend that you explore a little bit on their website to see what functions are available, and it can be helpful for you in the future as well as like final projects. So, in the first part, we start with checking out the data sets available on Scikit-Learn. Um, so here's a list of data sets available, and today we're going to use the breast cancer data set as an example. So in this data set, you can see some summary here about, like, for example, there are two classes, which is it's binary, it's yes or no. This data has cancer. Um, so let's start from using this data. It returns data and target, where target here refers to the label, the annotation, the class of this data. Okay, so let's start from loading. So for the whole Scikit-Learn package, it is to load it, use sklearn in your code. Import breast cancer. Um, so let's grab the data first. And we return data as X and target the label as Y. So when you need to run the code, you can use this. You can click here to run the cell, or you can also use Shift and Enter to run the cell. Okay, so it's done now. We have X and Y data in our code. Now, in part two, after getting this data, we want to split both X and Y into training and testing sets. So for this, Scikit-Learn also has this function that you can check out how to use it through the link. But basically, let's load it first. Basically, it returns X in train set, X in test set, Y, which is the target in train set, and Y in test set. So the input would be both X, the data, and Y, the target. And we can assign a random state here just for the function to randomize shuffling. Okay, so now we have the data split into train and test set. Now let's move on to pre-processing. So in sklearn, there are a couple, well, there are a lot of different pre-processing functions. So I recommend you go through this long list. So for like every different data set or model, you can try out these different normalization functions and see what happens. And also different functions fit different data type. Like today we're going to use the standard scalar, or you can also try a min-max scalar. And in some situations, we might need to use one hot, or like binarize. So yeah, you can check out the functions they have here, and the documentation can be pretty helpful. And today we're going to use standard scalar. So for standard scalar, you can also check out like what parameters it has here for you to set. What's the input and output, and here will be some examples for you to find out how to use it. Basically, you just fit the data and transform data. And in our case, we are going to use standard scalar to fit on the training set. So that would be X train. Oops. So after fitting, we need to transform both train set and test set. We can name it X train standard. That's the normalized set. Transform train and do test set. Okay. Oops. Okay. Let's run this cell. Okay, so now it's done. We have both sets normalized using standard scalar. You can try out other normalizations as well. The third part, we're going to use this preprocessed data to train a MLP model. So, model selection. Oops, it's not model selection. Neural network, and we will use MLP classifier today. So if you go to the documentation here, you can check out how to use it. Like for example, with this model that we're going to use today, there's activation function for you to choose and default is value, and the layer size is 100, and like there are just a lot of different uh, like many different parameters for you to choose, and also there are attributes to this um, model, for example the classes, uh, laws, and so on. So let's just do a simple trial here. Start from, we can name our model MLP. And without changing any parameter for this first trial, I just set the max iteration 20, random state. And let's have it print out the information when it's training. Okay, now we have the model. We can fit, which is to train on training set. And don't forget to use the normalized data instead of the data before normalization. Okay, so we're done here. Let's print out some information so we can learn more about this model. For example, let's check out what's the activation function. Which would be mlp.activation. If you're not sure about any of this, you can check out the website with the attributes we looked at earlier. And we can print, let's check out the class list. And the class list will be classes. Okay. Let's print the loss to see if the model is really trained, that to make sure that the loss is decreasing. Right, now let's run this up. Okay, so we can see like from the information returned from training, the loss decreased and the activation is indeed value. The classes are 0 and 1, which is correct because this is a binary data set. So this is the loss we get eventually. So with all that, we can build our own MLP classifier by setting the parameters you want to try. So let's say we have a second MLP model. And this time, we can assign the activation function we want. Say, I want to try tan H, and then hidden layer sizes. Again, you can go here to check out what you can change. So hidden layer sizes, let's do, say, 10 by 10. Okay. MLP2 fit again on the training set. Okay, so this time we can still print out activation function. And let's see the score of this model that I built. Let's check out the score on testing set. And for that, we will use model.score. And let's give it the test set, normalized test set, and ground truth would be y test. Run this. Okay, so this time as I assigned activation function as TNH, and it's correct. And we also got the accuracy score of this model that I built. So you can play a little bit with MLP classifier to find out which what parameters can bring you better score on the test set. Now, after all that done, we can still evaluate the model a little bit more using, first of all, evaluation metrics. There are plenty of evaluation metrics available on Scikit-Learn again, and you can check out here. There's a lot of packages to use. So we are going to first use the simple classification report here. And I'm just going to import it and see what it returns. Import metrics. So let's get a prediction first with the test set. Predict. And we can use the metric classification report. And the input would be y true and y prediction. True meaning the real ground truth of the test set. So let's give it y test as ground truth and y prediction. Okay, so this is what the function classification report returns to us. It has precision, recall, F1 score that you learn in class. Um, so yeah, there are a lot of different metrics, and I encourage you again to go through the list and try these functions out. It will provide you a lot of information on how well this model is trained. And the second part of evaluation, we want to try drawing, plotting a confusion matrix. So the confusion matrix function here, again, we need the parameters ground truth, prediction, and also there are there are a couple parameters to set up. So let's first do the matrix. We give it ground truth, y test, and the prediction. So now we have the confusion matrix. The next step would be to visualize it. So visualization is very helpful in machine learning and deep learning for you to like visualize the results, the evaluation, and also plotting the like um, the changes in loss or accuracy and so on. So here I'd like to introduce you some helpful tools such as Matplotlib. Usually what we do is import pyplot as plt, and also Seaborn is is based on pyplot, and it's also very helpful. So let's use these tools to create a heat map. So the information about these packages are provided here. I again encourage you to go through their documentation, learn what they can do. They can be pretty helpful. Um, so let's do the heat map of this matrix, and we can just do it without any parameters. So okay, it returns this heat map, and usually what we do is that we can customize this plot. For example, square, or if you want other like okay, I think that's it. And we can also name the axis, such as x label. X label would be a true label, the ground truth, and y label would be the prediction. Run it again. Okay, so this is our customized heat map visualization of the results from the model I trained. And we can see here that this is TP, is there are 87 samples in test set as TP. One sample was predicted incorrectly, and so on. So this confusion matrix helps us to understand how the model does on classification task. Well, let's move on to the last part. In the last part, we will practice how to visualize the trend, how accuracy score changes over epochs. So let's do, we need a list to store the accuracy score, and also we need to know which epoch that is. So let's do from 10 to 100 epoch, and every 10 as an interval. So we can train a new model here, MLP classifier. Again, give it a random state. And the max iteration would be epoch, and do fit to train on the train set. Ground truth. All right. So after training, we can get the accuracy score of test set, which is score and input test and y test. So for every time we go through this loop, we want to record the score that it got, and also the epoch. And after all that, let's see how the accuracy score turned out to be eventually. So I can print accuracy. The last one. And let's start with plotting using PLT. Plot the x-axis would be epoch, and the y-axis we want it to be the accuracy scores. And I would just select some styles here. Okay, so that's plotting. And again, let's do x label, which is number of epoch. and the Y label would be accuracy. And we can also assign a title to this picture. And finally, we need to use show for it to print out. Okay, let's run this. All right, so now we have this picture, and what it tells us is that after around epoch 60, the model stopped, the score stopped improving, and that means that we, for this model and on this data, we only need to train for about 60 instead of over like 100 epochs. All right, now that's everything for today. Let's do a quick review. So through this coding tutorial, we practiced how to run Python scripts on Colab. We learned how to use Scikit-Learn packages whenever you need some, it's either data preprocessing, models, or evaluation. You can always go to their documentations and check out what packages they have. It's a big library, and it's very helpful for you to learn what they can do for you to facilitate your future projects or works. And that's it for today. Um, if you have any questions about this tutorial, feel free to stop by my office hours, or you can leave your questions on Piazza. We encourage you to do that because your classmates might have similar questions. That's all. See you next time.